depletion. This is what we are going to discuss now. See, ozone depletion is one of the adverse effect of air pollution. Do you know what is pollution? Yes, everybody must know the meaning of the term pollution. Pollution is nothing but the entry of undesirable substances into the atmosphere. If it enters into the atmosphere, it must be air pollution, is it not? And this ozone depletion is the undesirable effect of air pollution. See, this ozone depletion occurs in the stratosphere. Stratosphere is one of the layer of the atmosphere, and I think you know what is atmosphere. Atmosphere is the air that surrounds the earth, and this air has many layers, and the upper layer of the atmosphere is stratosphere. In the stratosphere only there occurs a protective layer, we can say of friend, which is called as ozone. Ozone is formed in the stratosphere at high altitudes. See, the stratosphere is present in high altitudes. In high altitudes, ozone is formed. Ozone, chemically its formula is O3 and we call it as ozone. Chemically we call it as ozone. The formula for ozone is O3. Actually, this ozone is formed in the stratosphere by the action of UV rays. See, oxygen, that is molecular oxygen, is present in the stratosphere, which is in gaseous state. This oxygen, in the presence of UV light is converted into oxygen, which is in the atomic state. See, compared to the molecular oxygen, this atomic oxygen is very reactive and very unstable. So, this atomic oxygen again reacts with this O2 immediately and forms O3. O3, which is the ozone. This is also in the gaseous state and this one also in the gaseous state. Everything is in the gaseous state. This O3 forms a layer in the upper atmosphere and it acts as a shield, so that we can say like this, it acts as a filter. It filters the harmful UV rays and sends only the protective rays to our earth. So, these harmful UV rays will affect us and causes skin cancer. So, let us see what are the factors that causes ozone depletion. The substances that causes ozone depletion are called as ozone depleting surfaces. They are simply termed as ODS, ozone depleting substances, and the process of depletion of ozone layer in the stratosphere, it is called stratospheric ozone depletion. What is it? Stratospheric ozone depletion. Now, let us see what are the factors which cause this ozone depletion. Scientists say there are two main substances that causes ozone depletion are, one is oxides of nitrogen and the other one is chlorofluorocarbons. These are the major so many substances cause ozone depletion, but these are the two major substances that causes ozone depletion. Let us see one by one. The first one is oxides of nitrogen. Oxides of nitrogen. See, from where we get these oxides of nitrogen, how these oxides of nitrogen are produced and how they enter into the atmosphere. Have you thought of these things? Yes, these oxides of nitrogen are formed from the substances that we use in our day-to-day life. See, we use super fast supersonic jet planes, is it not? They give smoke as exhaust. Those exhausts contain lots and lots of nitrogen oxides, and when we burn fossil fuels or the fertilizers, everything contains oxides of nitrogen. Somehow these oxides of nitrogen are introduced into the atmosphere. But in the atmosphere, this nitrous oxide, N2O, you know, this is an oxide of nitrogen, nitrous oxide. This is inert in the atmosphere, but this inert nitrous oxide is converted into nitric oxide, but that nitric oxide is very reactive. That nitric oxide is the substance, only substance which reacts readily with ozone. So that reactive nitric oxide which is produced in the atmosphere reacts with O3, and this forms nitrogen dioxide and O2, right? Then this oxygen is converted into atomic oxygen. All these reaction takes place in the presence of sunlight. Then this atomic oxygen again reacts with the nitrogen dioxide formed in the atmosphere. See, this nitrogen dioxide reacts with atomic oxygen, forming nitric oxide and oxygen. See, this nitric oxide is the only problem. This is the substance that reacts with ozone. See, this nitric oxide reacts with oxygen, a series of reaction occurs, and again nitric oxide is formed. So ultimately nitric oxide is formed. See, this nitric oxide is responsible for these reactions. This nitric oxide reacts with the ozone present in the stratosphere, and the series of reaction occurs. Again nitric oxide is formed. So this reaction repeats until the ozone layer continuously depletes. So this is one of the major reason for depletion of ozone. Right, let us move on to the second factor, that is chlorofluorocarbons. See, chlorofluorocarbons are derivatives of methane and ethane. I think you know what is a derivative. Derivative is a substance formed from that parent compound. So chlorofluorocarbons are derivatives of methane. That is, we know the formula for methane. In methane, the hydrogen, if the hydrogen atoms are substituted by chlorine and fluorine atoms, then they are called as chlorofluorocarbons. But here chlorofluorocarbons, you know, they are otherwise commercially called as freons. The name is nice, is it not? They are called freons. You know where we use these chlorofluorocarbons? We are daily, in our day-to life, we are using chlorofluorocarbons. See, in refrigerators, air coolers, in plastic foam making process, we use chlorofluorocarbons. You know why they are often used? Chlorofluorocarbons are non-toxic, they are non-corrosive, they are non-inflammable, they are easily liquefiable. There are so many advantages of these compounds. That is why they are used, they are frequently used, they are abundantly used. So these chlorofluorocarbons are responsible for ozone depletion. See, there are two chlorofluorocarbons. One is CF2Cl2. See, instead of 4 hydrogen atoms in methane, there are 2 fluorine and 2 chlorine atoms. We can name this compound as difluoromethane. See, this reacts in the stratosphere in the presence of sunlight. Actually, a free radical is formed, Cl dot. You know what is a free radical? If only one electron is present as a radical, this is called free radical, chlorine free radical. So, CF2Cl. Then again there is another chlorofluorocarbon, CFCl3. Here also in the presence of sunlight. These are all photochemical reactions. So, CFCl2 plus again a chlorine free radical is formed. This free radical only reacts with the ozone. So, this free radical Cl dot plus ozone gives ClO plus O2. ClO, O2. See, this ClO reacts with atomic oxygen giving Cl free radical plus oxygen. Can you understand? See, this is one there are two chlorofluorocarbons are responsible for ozone depletion. Those two chlorofluorocarbons are these. This is dichloro-difluorocarbon and this one is trichlorofluorocarbon. In the presence of sunlight, the reaction UV light, the reaction takes place like this. Then this free radical Cl reacts with the ozone molecule and forms this ClO dot and O2. Again, this ClO free radical reacts with atomic oxygen giving Cl dot and O2. See, this free radical is formed here. Actually, this free radical alone can react with O3 effectively. So, this is formed again and again. Therefore, the depletion of ozone layer continuously goes on like this, causing a great damage to the ozone layer. So, these are the two factors we have discussed, the effects of nitrogen and oxides of nitrogen and chlorofluorocarbon, how they affect react with ozone, how they affect ozone layer, what are the consequences formed due to them. I think you all have understood those things. So many adverse effects are due to ozone depletion. One is mainly skin cancer, and the other one is the phytoplankton in the ocean. Everything gets destroyed. The protein in the plants, they get destroyed. There is a cell mutation. Cell mutation it's a kind of a biological process that takes place due to this ozone depletion. You know, when this one Cl free radical can react with 1 lakh molecules of ozone. They have found that one Cl free radical can react with 1 lakh molecules of ozone. See how these nitrogen, oxides of nitrogen and chlorofluorocarbons have an adverse effect on the ozone layer. I hope you all have understood the process of ozone depletion, and let us be aware of it.